This is the second part of Nigel's presentation on the production of a Fox 8-foot wheelbase bogie. This morning we heard about how Nigel produced the CAD design for the bogie and then 3D printed all the components. And this afternoon, I'm hoping he's going to tell us how he then, from his masters, produced the actual castings for the kit. So over to you, Nigel.
Thank you, David. Hello again, everybody. Yeah, it's been an interesting afternoon. I watched Nick's presentation. Was it Nick Paine about using multimedia ways of 2D, 3D CAD and everything, and it all
Yeah,
pretty much sums up what I've been trying to put across. Is that it is doable if you're a enthusiastic amateur. I don't think that there's any problem with it. If you can afford to buy a Loveless A4 Pacific or something like that, then you can afford to do pretty much what we're doing here today. So as David said, I was going to review what we've done, but as David said, we got as far as producing a 3D printed model. Where are we? There we are. So I think that might be in focus. So that's a 3D printed model of a Fox bogie side. And we concluded that we had managed to assemble a bogie and cart it to the UK, take it round Guildford Show, and it not get broken. So that's reasonably strong, but it's a 3D printed affair. And what I wanted was to do it in was to make it in white metal. So just as moving forward, then we take our 3D printed parts and we create a little pile of them here where we want to add them. And now we're talking about casting. I think the best thing is to do is to show you the machine, the magnificent machine. You're coming for a ride with me, gents. So look here. Ignore Bruna. She is interested. Can you see that? Or should I bring it up to you? That might be easier, mightn't it? It's not that heavy. It's a big box. And this will take up to a 10-inch disc. Ladles. And inside here is a big spinny thing here, which spins round. Nearly got my fingers. There is a hole in the top. And basically the principle is you have a ladle full of molten metal and you pour it through that hole. I think that is probably the hardest part of the whole process, is accuracy in pouring. But let's get stable again and move down here. The important bit is this, which is the actual mold which we have used to make the to make the master and into which to cast the model, the parts. For those that want to learn all about casting in white metal, I recommend that you find the Andy Duncan presentation, which will be far more professional than my effort. But as a amateur doing this actual process for the second time, that's all it is. This is the second time I've done this. This is what we do. The mold comprises of a disc, a series of, let's call them plastic components, which basically help to form the hole in the middle of the mold. Plasticine. Come on, guys. When did you last play with plasticine? And two of these very, I think it's Bakelite or something very similar, discs. The process is you take your disc, and in the middle of it is you insert a plastic plug. You put one of these on top, and it's locked in place by 3 screws, which you can see here. These actually will screw out because you need to transfer them to the upper plate at a later point, but we'll ignore that. And then basically the bottom half, which is actually the top half of the mold, you fill it with plasticine. It's called something else here. I can't remember, but it's plasticine or plastiline, it's called over here. And that gives you the basis for forming the top of your mold. Take one component. Now I've learned this is that there is an art form in making these molds, and I've had to relearn it because I got it wrong on the first one. All of the small detail parts like the springs and the details there are better off facing away from the center of the mold. This casts centrifugally, so by centrifugal force, the white metal is thrown out. And if you have it going to a thicker part, a larger component of the in the mold, and then allow it to flow out, it's much better than making it go into a really small point and then trying to fill the big void. So all that we do, roughly speaking, is place it on the plasticine. And what I'm doing here is I'm getting it so that it's halfway into the mold. And I've just pushed this down here. I'm not going to do it for every single component, but as you can see, you have it's sitting in the top half of the mold in a bed of plasticine. What you would do is, if it needed touching up, making a little bit better, is you could add little bits of plasticine in. You can smooth it out with a knife to fill it and make sure that the joins are sharp, because what you're going to do is you're going to put in all of these components. I'm putting them in roughly because I'm only doing this as an example for you, but you can see it all coming together. If I share and we go back to our Zoom presentation, here's one I prepared earlier. This is the first one that I did. So play from current slide. So this is one I prepared earlier, and we filled it with the components. We only need to do one side, one cross piece, one end break, one center break, one running board, and one top piece and the spring. You need to do one of those because if you cast it twice, then you get everything you need. Actually, if you cast it twice, some parts, some components like this and this, because they're only single, they would go back into the pot. But it's not particularly necessary. We also have, you can see here, some silver buttons. I don't have any upholstery buttons, which I was recommended, but I found these. These basically are feet foot that you put on the bottom of chairs, which allows you to scratch the floor quite well. So I've noticed. But those are used as shall we say, as a guide to telling you where to locate the two rubbers together. So they're quite important. One of them is larger than the others. I decided to do that because then that is the the point where you join them together. You will notice on here it has B and there's an arrow pointing in a certain direction. Basically, that is saying that that's the looking at the bottom of the mold, and that's the direction that the metal will flow. So the actual machine is spinning around in the opposite direction, but the metal will flow in that direction by centrifugal force, outwards and downwards. Now, ignore anything that is on this screen because basically I screwed up, with the exception of the this spring piece here. And this is an example of, this is from the first mold. The sprue coming out of it is horrible because it was the very, very, very first one that I'd done. And if name dropping again, Andy Duncan would shudder at seeing that, but it was the very, very, very first attempt. But I did manage to get everything to cast. I'll go through what that I will go through what that entails in due course. We'll go back to our little model here. So we have the mold. Let's pretend that we've put all of the other pieces in. I hope we're all good at let's pretend here. I would then insert this piece, which would then start to form the top of the mold. And pretty basically, I would lock it down. Pretty basically, I wouldn't do that. First thing I would do is you would need some mold release agent. So you just spray that over it to make sure that it's all clear and everything will release quite nicely. It's a silicon material, I think. You don't want to do it in your model shop where you do your spray painting. Word of warning. Because if it gets into the atmosphere and you start painting, your paint will bloom. Take it from me. Right. So we've got this, which is the mold. I would then go downstairs and do the messiest job I've ever done in my life, which is called mixing silicon resin, and the silicon, excuse me, just put my power supply back on. It's a red color material, and I would mix it up by weight with a catalyst, and I pour it into this hole here. I would put it into the machine and set it spinning at its slowest speed, so it basically centrifugally moved all the resin to the outside of the mold and hopefully blocked off prevented any air bubbles forming. If you have any air bubbles, you get something like that. Guess what I did? I followed somebody else's advice and didn't bother spinning it, and I've created a little crater there where the resin hadn't settled. I did it properly on this side, and it's lovely. So this is the mold. So the first part that we did was this bottom piece, which is this piece here. It sits in the bottom. So, but what we will have done is we'll have poured the resin in, and it will have filled up like so inside here. Leave it for, I left it for 36 hours because I went away on business and came back, and lo and behold, I've got a lovely, I don't think I can show you this, but I don't know how to do this. Let's pretend again. When I took it apart, I had a lovely mold, and for example, where is it? It is this one. And inside it are all of the all the masters stuck in here. Well, that's okay, that's fine. We clean it all up, reverse the process. So we take all of this plasticine All this plasticine will be removed. We've got the masters in here. We would then, removing the plasticine, there would be a disc free. I can't do that just yet, but we put the disc on here. This wooden disc that sits around like this, and spray with mold release. Spray, spray, spray. Make sure resin sticks to resin, and it sticks like to a blanket, if you know what I mean. So you have to be a little bit canny. Put that in. You insert some more of these nylon dowels to make a hole, which would be the feed for the. Basically, it's a hole. Yeah. Create a feed, and then take this out. You would put the lid back on this, and you'd repeat the process, and you would pour a measured amount of resin into the mold, leave it set again 36 hours. So it's not a fast process to make these molds. It's a couple of days to do it, 3 days, and then once that is done, unscrew it, and it's the moment of truth, and you lift it out, and inside there is you've got your mold waiting for you to take molten metal. You will notice that there's the big button here and the big negative button here, and they both slip together. And that's your mold. That is the mold ready for us to go ahead and make a white metal casting. So when you're ready to cast, you would do it this way in our let's pretend world. You would insert that. You'd have the two rubbers. You'd put the lid back on, like so. You have three. Can we see this? You have these three nuts screw down. Come on. I think it's full of plasticine. There we go. 1, 2, 3. Screw them down with equal pressure. Doesn't need to be overly tight. If you make it too tight, then it'll distort the mold slightly, and then you'll be getting slightly distorted items coming out of it when you've cast them. Put them into the machine. It's got a little location point on the machine, so it would sit in the machine on the spider, should we call it, which would actually hold it in place. You would then, let's see if I don't do my back in because it's full of white metal, of this little monkey. This is a pot full of white metal. You look in there, that is white metal. It's a lot of white metal. Plug it in, turn it on, set there's a temperature setting. There's a digital setting here which will tell you the temperature to set it to. I guess I could splash of color. I'm doing this right. Right. And basically, you can see here, this thing is on, and it is going to slowly heat up. I am not going to leave it. It takes about half an hour to heat up, but it will heat up to the temperature of your choice, which I think the recommended temperature is, well, let me get this. There is, I can't remember the two names, liquidus and solidus. Is that right? That might be the correct technical term. Solidus is the point when white metal or any liquid turns to solid. So be it water freezing to ice, or be it white metal solidifying. It's called solidus. Then there is liquidus, which is the temperature point at which white metal, or any metal, but let's call it white metal in this case, turns to becomes a liquid. Um, and what they recommend is that you actually run it at about 60 degrees higher than that temperature, because you will be ladling white metal from there and pouring it through that hole that I showed you on the machine, which will be spinning and filling, going into this hole here. And it's not the hardest thing to do, but when you're dealing with molten metal, you'd probably be a little bit hesitant, shall we say. But
Can, can,
what I
can I
found,
ask you, Nigel,
yes,
that melting pot that you've got there, can that only be used for white metal? I, I mean, will it go up any higher temperature
well, it'll
than?
go higher. I can't remember what the maximum temperature is.
I mean, for example, could you melt nickel silver in it?
I don't think you could melt nickel silver. You can do pewter, which I think has got a higher melting point. Um,
Hmm.
the interesting thing about this is that the company that I bought the system from um, didn't send me any instructions for the melting pot, and I looked up on the internet where this melting pot, you know, for details, and I found that actually the company I bought it from didn't make it. It turns out that it was made in Keighley,
Hmm.
where I used to live, and the guy who I spoke to, he knew all about drinking Timothy Taylor's beer, so yeah, we had a lot in common. And he told me that yeah, they do a variety of machines. This is, shall we say, the basic amateur version, but they do a lot of metal melting equipment. In fact, they do a lot of different casting equipment, um, and certainly they do very big centrifugal casting machines. That machine that I've got here is a very is a very basic model, but casting white metal, it seems to be a very basic process. But it's a little bit fraught because you are pouring white metal, or you're pouring a molten metal into a hole. But
Just so that we all get understand the sequence, Nigel. Um,
yes,
so you start off with plasticine, into which you press your 3D printed components.
yeah,
With,
the
with,
plasticine is basically representing the, shall we say, the top half of the mold, which isn't there. So yeah, so carry on.
so you then remove your patterns.
No,
No,
no, the plasticine is effectively the top of the mold.
yeah,
Yeah. So when you first make it, you're working upside down. So you have the plasticine, you push the patterns into the plasticine to get and position them at the right level. When you make a white metal, if you're assembling a white metal kit, you'll always see a line around the kit, which and there might be a bit of sprue. This one doesn't have none of mine have a sprue. Oh, there's one. Right. So you'll have a bit of sprue like this here. Can you see that?
yeah,
Yeah.
yeah.
And that is the join between the top and the bottom mold. So the first thing that you do is you put the plasticine in to represent the top half of the mold, which doesn't exist yet. You put the masters in, pour the rubber into form what is basically pour the silicon in to make what is basically the bottom half of the rubber.
Right, got you.
When
Yeah,
you've got the bottom half of the rubber made, then basically you've got all of your masters, shall we say? It's a bit difficult to point out. So you've got all of your masters here, yeah, But then you need to make the mold for the top half. So you don't take these out. These masters stay in place. You spray a coating of mold release agent across it, which is a silicon based thing, which it stops the top and bottom half of the mold sticking together.
Yeah,
If
got that. Yeah.
you don't do that, then you're screwed. So you've got to make sure that you do that. So then you've got the bottom half with the masters in. You put them into the cast into this, and you once again you have a hole. You have a hole in and then you pour the resin in for the top half, and that forms around the masters. Yeah,
Yeah, gotcha.
it's set. Unscrew the mold, release the lid, and inside you will have two halves. You open that up, and then you remove the masters. And in removing the masters, you will then have two, shall we say, negatives. You have a negative.
Yeah, gotcha.
Yeah,
Yeah, thanks for that, Nigel.
it's all right. So
Can I just ask at what point you cut in the sprues then? And is that into both sides?
yeah, yeah. So this is where the art of 3D of casting really takes its own. All of this is done literally, but it's like by the machine. When you come to cutting the sprues, uh, you cut the sprues once you've made the two molds. I have debated about this while I was doing it. That's how I'm told how to do it. In my view, I wondered whether you could put in some channels, be it out of a bit of brass rod or whatever, or anything, 3D printed even, and insert them into the mold before so you actually do it as part of the process. Um, because this cutting of these channels is an absolute pain in the butt.
Yes, I've seen Roger Shiver do that.
Yeah.
Roger Shivers, I showed him how to 3D print so that he could do exactly what you're doing there,
So
but on a
3D print
commercial basis. And he does put in sprues and things
yeah.
into both
That's
Yeah,
sides. Yes, yeah.
and Andy Duncan does the same. He cuts his sprues with a scalpel, basically.
yeah, yeah.
Hmm.
So
Yeah.
you cut the sprues with a scalpel, but what you're basically doing is you're cutting a channel in the rubber, and I got incredibly nervous about cutting that. And, Dougie, who did roundfield engineering, so it's easy, you know, like a master surgeon. You cut them all right. You can cut them; it's not a problem. You need to know where to cut them. You need to sort of find a way of where to point them at the best point within the mold, and where to do it. You only do you do one side, and then you get some of this stuff, which is the messiest stuff in the world. I bought far too much of that. If anybody wants to buy French chalk or talcum powder, it's not the smelly stuff. This is proper industrial, non-smelly stuff. You take some of this French chalk and you put it on, you sprinkle it, spread it across this half of the mold, and then you put the other half on, press them together and take it off, and then this half will have a chalk mark showing where all the sprue lines are, and so then you can just repeat from that side. But I'd be interested to find out what people, from the experts, whether it is easier and better to actually put some, shall we say, some sprue, even partially sprue lines in there, made out of, I don't know, bit of brass, bit of anything.
Yeah. Um, in the casting of well, iron and aluminium, which I'm vaguely familiar with from my past life,
Yep,
um, you have to provide what they call runners and risers, and the runner is where you pour the metal in, and the
yep,
riser is where the air is allowed to escape.
yes,
So, how does the air get when your metal is being spun into the cavities in your mold?
yeah. Where does it go?
Where does the air, which is trapped effectively, where how does that escape?
One thinks, I think, that it obviously comes out through this tiny little gap, because that's how you get these sprue lines. When you
Mm,
buy a kit and it's badly cast and you get really bad sprue bits of sprue coming off there. I think that's what happens. There is I haven't done it, but in the instructions or the guide for doing this, one of the things it says is what you can do is you can drill a hole up to 1 millimeter in in the mold and allow it to, in the hole, you know a hole
yeah,
there, so it'll allow
yeah.
yeah, it'll be a riser. It'll be a riser. um yeah, so
Yeah. Can I just say?
yes, of
Um,
course.
yeah, Roger. I've watched him do this many times, and he does some of that. He does also, if something's not coming out because there's air in the way, he literally just gets his scalpel and just takes it from the corner out to the edge of the rubber,
Of the rubber.
and that just provides enough of a space for the air to go, and then it'll fill with metal next time he pours it.
Yeah, I think that would work as well. The interesting thing about this is I'm talking as a total amateur on this, because this is the only mold I've made. But then Dave asked me to do this presentation, so um, this is a warts and all presentation. This is not a sexy professional one. This is a warts and all thing, and this is the first mold. I'm going to do another one so that I can cast these better, because I think I can. And quite basically, this I can make it cast some of these, but if I wanted to produce 100 of them, I couldn't do it with this mold. And apparently these molds will last for 1,000 plus. If you look after the rubber, then it'll cast and cast and cast and cast. I don't know what to do if I had 10,000, but uh, 8 foot fox bogies. But yeah, that's what I could do. So when you come to pour, you set your machine spinning. It's a centrifugal machine, so basically there's an electric motor on the bottom and it's slowly spinning around. You can set it to whatever speed you want and adjust it. I set it to about half speed. It goes 0 to 10, I think it is. So you set it at 6 and now it's spinning around. I'm not going to melt any metal because it's very, very messy. I did strip that off, didn't I? Yeah. And I just find a big puddle of molten metal on the floor here. My wife would kill me. Um, it's held. The rubber is held in here in place so that it's nice and tight, and you're pouring into this hole. I definitely think there's an art in this and a knack to it. The first time I poured it, is I had a ladle full of white metal and poured it in, and of course it all slopped over the edge there and centrifuged itself around the inside of the machine. At no point, whilst when I bought the machine, I'm thinking this is dangerous work. White metal. I mean, all right, it's only 400 and something degrees that you're working at, say. It's not even that, is it? But you really don't want white metal going up and down your leg, or running down your leg, or getting in your eye. Once I started casting with it, there was no absolute. I started off with gloves, and I do wear eye protection, but at no point did I feel that there was any danger. So I hope that reassures people that are thinking about doing this. At no point did I feel that there was any danger. All that you're doing is you're pouring white metal into a hole there, and that is basically target practice. And us blokes should be good at that sort of thing, shouldn't we?
Many years ago, when I was into military modelling, there was a company that used to produce masters for casting your own white metal figures,
Yep.
which you just heated up in the ladle on the gas stove and then poured it in. So it was you didn't really, and they didn't suggest gloves or anything. You just did it. So it can't be that dangerous.
I don't think it. I knew you probably found the same thing. You didn't feel that it was dangerous in any way. The lovely thing about this as opposed to pouring it just using gravity is by using centrifugal force is that it forces all of the, well, it gets rid of all the bubbles and it forces the metal into the corners and it forces it in very quickly. So it's incredible how good these castings are. I did buy a kit to build a Class 15 diesel locomotive at one point, and I think that the castings for that were poured without using any centrifugal force, and they. I think Nick Dunhill's got the same thing. He's got a bin where he puts all those things. I was in the UK last week, and my friend Robbie, these aren't necessarily all rejects. He gave me all of this white metal, and he says, "Yeah, these are for the pot." And I've put a lot of white metal in the pot, but from old. I had some old kit parts that I had which I never used, so they'd just gone in the pot. Reuse them. So it's a very green sort of process. You can reuse it, and you don't throw anything away. Even the liquid rubber, when you pour it, if you've got too much, I got a tip that you can pour it into a flat dish and let it set, and then when you're making a new rubber, is you use some of that rubber, cut it up, and you can use it in places because it all goes in and it can just go around it. It's a very economical way of doing it. I'm a Yorkshireman, for God's sake, you've got to save your money somehow. When you pour, it's fascinating to see, it's very nice to see. You pour the metal into this hole, and you see it disappearing, and then suddenly you'll see a little ring of silver white metal forming, and that's when you stop pouring, and basically you leave it running for a few, maybe 20 seconds or so. Stop it. Leaving it running allows it to heat up the mold, and by heating up the mold, it gets it to an optimum temperature for casting. When you've done it, you loosen off these screws, take the mold out, and inside would be you saw the photograph earlier on, would be a lovely set of bits of white metal on sprues, and you can take the whole thing out and either right away snap them off if you wanted to, or reassemble the mold, put it back in again, and cast again. If you keep the mold reasonably warm, then it seems to cast better. That's what I've been told, and that's what I've seen. I was happy with that as well. So, Christ, we've only got 14 minutes to go. So we ended up with a load of white metal bits. Here we go. I had quite a lot of bits of white metal to test it all out. As you can see here, warts and all. This is the problem with the sprue being cut wrong, is that there's a great big chunk of white metal on the end of this. Can you see that? Not very nice. You can cut it, of course you can, but it would be nice to have it so that when it was cast, is you snap it off, which is how the professionals do it. But what I found with this one, is that when it was finished is that literally slots in perfectly as designed, as I wanted it to do. And the idea, you can see that there's like a U shape cut out there, so that then what I was going to do is to, when this slots in, is that it gives you somewhere to solder it. Yeah, so I just run a bit of low melt solder around there, all soldered up in low melt solder. I am using, there are other makes, but I'm using Cars 70 on this one. Yeah, but there are plenty of other makes. I think Dougie, name dropping in, Dougie Hay said he solders everything in 70 in Cars 70. Yeah, it's only but it runs into, and it makes a very strong assembly. So
do the axles run directly into the white metal, or are you using
no, I'm
bearing
using
cups?
Right. I am using, and this is specific to part of the project that I have to make Fox pattern bogies with kits and wheels. You can't get kits and wheels for love nor money. I'll tell you that. You can't get them in O gauge at all. You can ask me, because I've done it. But this is a kits and wheel, right? I'll see if I've got. I'm sure you all know what a Mansell wheel looks like. I'm not opening this up because I've got loads of them, but that's a Mansell pattern wheel. That's a Kitson pattern wheel. So, so the Mansell one, the center of the wheel has a load of lines running out to the edge, which basically represents these teak, I think, certainly hardwood wooden blocks that go around the wheel to hold it in place. If you saw the first presentation, is that the hardwood blocks are much smaller, and they basically go between the tire and the, what's the center part of the wheel called? Rim? That's not to sound right.
Center. It's called the center.
The center, right? Well, you've got, yeah.
Oh.
Yeah, all right. We'll call it the center, but in this case, you can see that that is a pretty good representation of a Kitson wheel. These wheels, I'm going to recommend this company because if you're going to make your own Kitson wheels, that's what you need. These are pear tree axles. They are designed as to take Mansell wheel inserts, but he will supply them without the Mansell wheel insert, which is basically an etched brass part. So he'll leave those out of the kit and then allow you to fit. If you can get them from me, or you can make them yourself, you can fit your own Kitson wheel inserts. The outside one is obviously, I had one which I prepared earlier, didn't I? Here's the outside one that you can see here is a full circle, and the inside one is two halves, because you've got an axle in the way, so you just glue them in on either side, and that gives you that. They fit in with a with the bearing provided by the company, and the way I've designed it is that I think you need to run a drill down it, but they fit flush against the end there. So there is a little boss in the, if you look at the white metal here, there is a little boss that sticks out there, just enough so that when this half, and it's easier to do it with one I've prepared earlier. What have I done with them all? So that they both fit exactly in the right position. So there is absolutely there's about 1/2 mil side play, and that gives you enough so that the wheel will spin. So I designed, that's how I designed my Fox bogie. It has.
Is there any slight up and down movement in those?
No, No. So when they were soldered together, I know what you mean. I know what you
Well,
mean.
I'm just thinking for scale 7.
All right. Well, yeah, yeah. So if your scale, so this is my telephone, and I actually assemble mine on a bit of glass. Not necessarily my telephone, but sorry, that's my telephone, and it's assembled on a piece of glass. And because this U section piece at each side is so accurately cast machine designed, is it actually just slots in, so it does actually hold it in place. And then you solder. God, it's terrible, this, isn't it? Solder in the four corners of this top plate, and it will and check it. And if it is square and the wheels aren't rocking, then I'd solder on the end pieces which go across the cross pieces, and then this further center piece which has got a have I got one here? Yes, I do. Here we go. This is for the brake on the shall we say on the center part of the bogie, and this piece adds a bit of strength to the bogie. It's all about sort of white metal can bend over the years, but this is like a solid girder going across just like the real thing. That's another good company I remember. And then the only other bit that you probably wonder about, which I'll show in some photographs, is this little center spring part. And the best way for me to show you this is to share and to go back to this PowerPoint. So you can see there's the castings. That's the Mansell wheel insert, as that's comes straight off the computer as I've drawn it. There's the bogie as is. There's a floor, warts and all this presentation. There's a floor there because there was a bit of bubble of air underneath there, which has spoilt that. But then you can see this this part here, this spring part, which I showed you here. Oh, I can't show you, can I? That was very, very difficult to cast. You can see on the axle boxes it says NERB on both of them. So I was quite chuffed with that. If you look really close, that's the real warts and all thing, isn't it? There's a bit of sprue, something there that needs cleaning up. It could do with cleaning up there. You probably won't notice it. What I do like is on the top of here, you've got all of these rivet heads, which going back to the good old Cavalier bogies, they didn't feature it. Dougie's don't feature it, but mine do. So I was very pleased with that. I think that's all of the. Yeah, that's all of them. So yeah. So
well, I mean, are there any other questions that anyone would like to ask of Nigel? Well, I will ask another question, Nigel. I mean, how expensive are these melting pots and centrifugal casting machines? I mean, I'm guessing that they're well affordable now by your average modeler.
Well,
I mean, yeah, comparing them with the likes of 3D printers. I mean, we had a demonstration of a 3D printer about 5 years ago at our local club, and a chap proudly announced that he'd paid 4,000 or 5,000 quid for it. But you know, you can get them now for sort of 200 quid. In fact, my grandson bought one off eBay for 20 quid. It works perfectly, you know. So everything is now affordable for the home hobbyist,
the
isn't it?
market.
You can get a resin printer for £80 now.
Yeah.
2K,
Really?
2K resin printer for £80.
Yeah.
Mm.
I think I paid about for the Elegoo printer, which is allowed upstairs because it's very cold over here, so the resin needs to be warm. That cost me something like 300 quid, I think. And like I said about the casting machine and the melting pot, forget about the materials. The casting machine and the melting pot as the sort of capital equipment is less than the price of of a Loveless A4 or Lionheart, whatever it is. So if you can afford to buy a big brass ready to run imported loco, dare I say it, you could probably afford to do this as well. The company that manufactures that sells all of this kit is called Pottery Crafts or Tiranti. If you think about Ferranti, I know what Ferranti is. So, but yeah, Tiranti, Tiranti. And if you look up there, you can see what they do. And they only do one casting machine. And I'm chuffed. I'm pleased with it. I hope that I will get enough out of it for it to pay for itself. But certainly I'm able to make my models how I want them. I've just, because we've got 2 minutes to go, and I promised that I would do that. I've just got to the point where now that these bogies are finished, I'm working on now. Going back to what Nick said, it's 2D design, and I've designed some 2D stuff, which if I can find it, it's here. So this is what I am designing at the moment, and if I can move that out of the way, I can whiz this around a bit, can't I? It's a four-wheeled coach dating back to about the 1870s, 1860s, 1870s, and it's basically layered in. It's got 3 or 4 layers of plywood, very thin plywood, 0.4 millimeter. The base of it is 3 millimeter ply. The buffers I've just dropped off the masters for those, and the steps as well, and the end steps, they've all been dropped off to be cast in lost wax. And this bit is going to be white metal. And this is now called in my household. Oh, that's no point. I can't show you that, can I? Come on, where have you gone? There we all are. This is now called the Good Book. Peter will recognize that. Thumbs up, Peter. Yeah. And this this particular item is called a composite smoking carriage built in 1871. And it's Stockton Darlington, and I don't know of any other Stockton Darlington vehicles that are available. So I've decided to make it myself. And guess what? It's got Kitson pattern wheels.
Don't forget that coach still exists.
Yes, is it the one on the Worth Valley?
It's the one that's part of the old gentleman's carriage. It was extended into a bogie carriage and then extended again. So it's a bit like George Washington's axe. It's been chopped and changed around a bit. But some of the woodwork in that coach is the original smoking carriage.
It definitely is, because you read about this and they say that it was a 6-wheeler, but it wasn't a 6-wheeler at all. No. Well, that's very interesting.
There was a presentation given by someone who presently owns the gentleman's carriage at the Nera in London about 10 years ago. Unfortunately, I don't think copy was ever kept, but the person who owns the carriage knows the complete history of that. That's when I first learned about that.
Well, that's good. That's good. So, moving on, scratch building bogies. We're now designing our own models. I think the hobby nowadays is that okay, you can buy ready to run stuff, but if there's something weird and wacky and wonderful that you want to do, Peter and I want to have a rake of Stockton and Darlington coaches, don't we?
I've got the engine to go with it.
Yeah, so we're getting on with it. Hopefully by Kettering, I might have some wood cut. So see you there.
Okay, good.
Right, well, Nigel, thank you very much again for another fascinating presentation. I think that's another black art that's been explained to us all, or several black arts actually. You know, through resin casting and 3D printing, and certainly white metal casting. So, on behalf of everybody, I will say thank you, and we shall see you at Kettering. And I thank the rest of you for your attention, and hope you found it interesting and enjoyable.
Thank you very much. Very good.
Thank you.
Okay.
Thank you, Nigel.
My pleasure. Thank you.
Yes.
Brilliant.